Good evening, everyone, once again, and welcome to the Geo Institute Masterclass series on AI and Data Science. Today, we are hosting session 3 of the 5-part series titled Build Your First Model, a hands-on introduction to machine learning. In this session, we will explore the fundamentals of building a machine learning model, understand the key concepts behind data-driven insights, and discover how AI is transforming real-world applications. We have already completed session 1 on decoding future with AI and data science, session 2 leading in the AI era, the human machine alliance, and we are excited to continue this enriching learning journey. It is my pleasure to introduce our distinguished speaker, Mr. Manaranjan Pradhan, founder and director, AwesomeStats Consulting Private Limited. Mr. Pradhan is an IIM Bangalore alumnus with over 20 years of industry experience in the big data and machine learning. He has worked with the leading organizations such as TCS, HP, and iGate, leading large-scale projects for global clients including Motorola, Home Depot, and P&G. A seasoned consultant and trainer, he has been teaching big data and machine learning for over 7 years, training more than 1,000 professionals from top MNCs including EMC, Cisco, Goldman Sachs, and Accenture. He also serves as an adjunct faculty at IIM Bangalore and Indian School of Business, Hyderabad, both among the world's top ranked business schools. He is the author of a best selling book on machine learning using Python, published by Wiley. Welcome to the session, sir. Over to you.
Thank you, Minal. Am I audible?
Yes, sir.
Okay, so let me share my screen. Is it visible?
Yes, sir.
Okay, good evening, everyone. What I'll do is in this particular session, I'm going to first talk about three things. The first is why machine learning. So to understand that what enterprises were doing before machine learning and why people have started machine learning or adopting machine learning after that. And then we look at one simple case study or a use case where machine learning can be applied in the real world, right? And we also look at a couple of use cases. For this session, of course, we don't assume that you have any prior knowledge or programming knowledge. So I'm going to use an UI tool or visualization tool called Orange to demonstrate how to build models. And how simple it is to build models. So let me get started. So what is machine learning? As one of the best definitions of machine learning is given by MIT. It's a field of study that gives the ability to learn without explicitly being programmed. That's an important aspect of machine learning, that we don't explicitly write rules. So that brings us to the question saying that what are then explicitly programmed systems and how different they were compared to machine learning. If you look at enterprises, across different industries, whether it's insurance, retail, finance, or any other industry, people were taking decisions for a very long time, right? Business decisions. And those decisions were primarily rule-based, what we used to call rule-based or expert systems. And enterprises have been using it for a very, very long time. For example, a simple example would be like whenever you do initiate a transaction, like you do a transaction on a point of sale device, or you do a transaction over e-commerce site, right? All this Am I audible? Yeah.
Yes, sir, you're audible, but your screen is not visible.
Give me a second. Yeah. So all these transactions, right? Whenever you initiate, most of the payment systems typically have a model which predicts what is the likelihood of that particular transaction being a fraud or not being a fraud. Now, what kind of systems are no, these systems are built on? So traditionally, they were actually using something like rule-based systems or expert systems. And for example, these rules would be dictated by the domain experts who would have understood the domain very deeply, and they would have come out with rules. And some of the rules are very static rules, and some are velocity rules. For example, whenever you initiate a transaction, what's the transaction amount, from where the transaction is initiated, right? And for example, the IP address or even geographic location, which merchant location, all these are typically static rules, and there have rules based on that, which can detect it's a fraud or not a fraud. Or they can also be velocity rules. Velocity rules, for example, which could be specific user behavior. Imagine the user typically spends about maximum 50,000 rupees in a month, and the highest transaction is about 50,000 rupees, but all of a sudden the user is actually initiating a transaction amount which is much higher than that, right? So it could be a suspicious transaction. They look at users, over a period of time, what's a moving average spending. And then if the current transaction amount is much higher, then it could be highly suspicious transaction. Typically, you would also encountered whenever we buy something very high value, typically we get a call from the bank saying that, do you really, are you really initiating this transaction? It is a fraud or not a fraud, right? So these are like velocity rules. So a lot of these rules typically have evolved over a period of time, and people have explicitly written those rules in the system or programmed them using like if-else conditions. And whenever a transaction gets initiated, if any of those rules or some of the rules get satisfied, then the transaction is rejected or transactions are approved based on the rules. Yeah. I'm just quickly checking if the audio and everything is correct. There's a power failure here. Am I audible? Okay. Okay. So now let's look at one more. For example, everybody is aware of CIBIL score, right? So the CIBIL scores also, or any other credit risk scores, also typically people were using or enterprises were using credit risk rules. For example, if any of the payments, past payments have delayed, right? If more than 60 days late on any payment in the last 12 months, then your credit score reduces by certain points, right? Or any credit utilization rules. For example, if the credit card utilization is more than a certain percentage, right? So that means you don't have enough cash flow. You're primarily depending on a lot of credit. So that itself reduces certain scores, right? So similarly, the lot of these rules are, have evolved over a period of time to determine what's the worth of, your credit assessment. And what happens is over a period of time, the number of rules also increase and they also become extremely complex. And the underlying business context also changes over a period of time. For example, in case of fraud detection, we always see the new fraud patterns emerge very quickly. Now, how long it takes to understand those patterns and again develop those rules and put that into a system, it takes quite a long. In fact, there is a study which takes about 400 to 800 hours of understanding those new patterns and put that into in the rules. And within that duration, if the new pattern has emerged, and until we actually develop those rules, understand the rules, and put that into a system, we're exposing our enterprises into a lot of risk. So these rule-based systems, though they were quite widespread in the past, but they're very hard to adapt to changes very quickly, right? It takes a lot of time to understand and dictate those rules into the system. Second one is, of course, through simple rules, we can't, encompass a lot of complex patterns in the data, right? If else rules can only contain or probably detect, frauds or risks, very simple rules. The complex rules cannot be encompassed into the if else conditions. We probably need a much more complex mathematical, equations. So one is the very slow to adapt to changes. Second one is only simple rules can be dictated through the rule-based systems. Complex rules cannot be, patterns cannot be detected by these rule-based systems. And they're also difficult to maintain because over a period of time, the number of rules that you put into the systems, they increase. There become a lot of nested rules, and any slight changes to those rules can actually break the whole system itself, right? So any changes takes a lot of time to test, verify, so that the systems remain robust. So what happened is, to overcome these challenges, people started looking at algorithms. So rather than the domain experts understand patterns and dictate those rules, now can we have algorithms, right, which can look in the data, in the past data, and then detect those rules automatically. And those rules, the algorithms can express in terms of if else conditions or can be also mathematical equations, right? And algorithms typically can detect rules much faster compared to humans. So it also helps you to adapt to changes much more quickly. So algorithms can actually help you to understand patterns very quickly. They can actually capture extremely complex patterns, and managing the changes to the patterns or the detected patterns by the algorithms can be also much easier because you can have a change version system, control system. So what happens nowadays through machine learning, we can look at your historical data. For example, in this case, we can look at your, fraud or non-fraud data. For example, you can look at so we'll actually take up questions at the end. So okay. So we can look at the historical data of frauds and non-frauds, and then feed those to the algorithms. And the algorithms, what they do is they look into the data, and when we feed the data, we can actually feed certain factors that might be impacting those frauds. For example, the transaction amount or the location or the merchant ID, right? All this information along with the past transactions. And in the past, if you have detected those frauds and non-frauds, the algorithms actually find some kind of patterns in the data. And those patterns now can be deployed as a models, right? And so what happens is, once algorithms detect those, let me quickly show you. So here is the historical data where we actually can provide something like transaction amount, right, or location, or any other information like a merchant location, right? Or IP address or whatever information about the transaction. And if that particular transaction was a fraud or a non-fraud in the past. So we have a lot of this data which were frauds or non-frauds detected in the past. We can actually provide this information to the algorithms. So algorithms basically find the relationship, what is the probability a particular transaction is a fraud or not a fraud, okay, as a function of all these factors. And finding this particular function is basically your model, right? And that can be now deployed onto the systems, and any new transaction comes in. Now the function typically predicts the likelihood or the probability of being a fraud, and based on that, we take decisions. And the beauty of this approach is sometimes the model detect a transaction as a not a fraud, but it is actually a fraud, right? So that's why your banks typically give you 24 hours or 48 hours to report frauds. Or if the model finds something as a fraud, but it's actually not a fraud, right? So now the new samples get created, the new data get created, right? And those samples can be brought back into the earlier data, historical data, and we can run these algorithms to find the new functions. So let's say the earlier function is f1, now you can find the new functions f2, okay? That means the new model, again quickly deployed to the systems. So the cycle of creating these models can be shortened or probably reduced to significant. For example, one of the studies says that on the leading payment provider, which is reduced from 800 hours for detecting new patterns to almost 40 hours now. So that's a significant reduction in terms of finding new patterns. So the exposed to risk earlier, which was very high, has been reduced significantly by adopting machine learning. All right. So if you want to do machine learning, there are three important aspects that everybody or every practitioner must understand. One is the data, right? You should actually have a very good understanding of your domain and what data is required to build machine learning models. Okay, so that's where the real value is there on curating the right data for building models. Okay, and the data should actually represent the underlying business context for which you are actually solving problems. This is actually input to a machine learning model. The output is basically the model itself. That means the function, which can be a mathematical expression or a set of rules. The algorithms also has the ability to spit out certain the rules, right? And there are algorithms which actually, look into the data iteratively and find out any patterns that exist consistently in the data and spits out of the model. So you need to have a good understanding of the data, which is input, a good understanding of the model, what is the output, and how to interpret that, how to deploy that, how to understand that, right? So what kind of function you want, right, to represent your pattern. And then you also need to understand which algorithms will actually help you to find certain patterns in the data. So you need to have understanding of all three: the data, the model, and the algorithms. Now, typically your ML lifecycle contains these phases. The first one is use case identification or problem formulation, which is the typical ML problem, right? Starts with understanding the actual business problem that you're trying to solve and converting that into a machine learning problem. That's a really important aspect. Okay, so first you identify the use case, and then you formulate that into a machine learning problem. So it's like a prediction problem. And then based on that problem formulation, now you go and collect data, right? And the data could be internal to your organization or can also be an external to an organization, right? This is where most of the time spent nowadays for machine learning, right? About 40 to 50% of the time actually spent in collecting data and exploring the data as well. So you do a little bit of what we call EDA, exploratory data analysis, where you look at what the quality of the data, the data is clean, right? If the data actually follows certain assumptions that is required to building machine learning models, right? You look at all that, this aspect. So you clean, right, and prepare your data here. And then you go into building machine learning models, right? And once machine learning models are built, you have, of course, you have to validate them as well. And if the model validation says the model is not useful, not good, then you might have to come back and again collect more data, prepare them, and building a model. So this is like a from step 2 to step 5, it's more like an iterative step, right? So you keep on doing that until you find a model which is deployable, right? And then you go and deploy the model in the real world. Of course, then you also have to monitor the model and all that. That's an additional step, a little advanced step. But here, typically, the ML life cycle, right, which is shown here, starts with the problem formulation. Just give me a second. So it starts with the problem formulation, data collection, data exploration, building models, validating, and then deployment of models. Okay. Now let's look at one, as far as one of the most important, use case that we encounter every day, which is actually solved through machine learning, is ETD, is expected time of delivery, right? So whenever you order through Zomato or Uber Eats, or in fact, whenever you book a cab for Uber or Ola or whatever, right? Any of the providers, uh, the amount of time it takes to deliver that particular order, right? In case of food delivery, or estimated time for arrival for Uber and Ola and all that, that typically are solved through machine learning, because there are a lot of factors which influence that particular time, right? So Uber Eats, as an article says, that improved the estimated time for delivery information accuracy almost by 26% using machine learning algorithms, right? So earlier they probably were using rule-based systems, but now they have improved that estimated time of delivery. And why that is important? Because your ETD, estimated time of delivery or expected time of delivery, builds a trust with the customer, right? So if you fulfill that, okay, once you promise an ETD and you deliver within that, then it actually builds a lot of trust with the customer. But if you violate that, right, you actually the mistrust happens. So that's why it's very important that you have a right mechanism, a right model to estimate these times, optimally. So let's look at one simple example for our use case here. For example, let's say you want to build a portal, right? A portal for what? A portal for resale of used cars, right? And then the kind of features that you're going to provide is, let's say, you're going to list, you want to allow, there'll be, of course, a seller and the buyers, right, will be in the platform. And the sellers would typically come and list their cars with the features and all that. And then buyers will search based on the requirement. And of course, the seller will also quote a price, and the buyers will bid for a particular price, and then the transaction happens. Now imagine you have observed this transactions over a period of time, and your sellers and buyers basically say you that, okay, they are not very satisfied with the platform, because sometimes when the seller overquotes a price, right, then it takes a lot of time for the transaction to complete. Or the seller also underquotes a price, the transaction might happen quickly, but it might lead to dissatisfaction. So what happens is, now we'll say, okay, let me provide a feature for you, right? The sellers and buyers saying that, okay, you just upload the features of the car, and we are going to estimate what is the best price at which you can actually sell the car. So how to estimate the price at which the car can be sold can be one of the features that you can actually add to your offerings to the your customers or users, right? But the question is, how do you actually estimate the resale price of a car, right? So the resale price of a car could actually depend on many factors, right? So I will give a minute here for the attendees, participants. So can you uh, put in the chat window what are the some of the factors that actually affect the resale price of the car? Can you put in the chat window? Is it possible for the participant to write in the chat window?
They can write their questions in Q&A section, sir. So we have one question actually here. I can read it for you.
Can they write the answer to this question that I'm asking?
I'll just check. Yes, sir. They have mentioned in Q&A section. You can see their answers.
Okay. Okay. I'll just give you a minute. Can you just write it, participants? So, how old the car is? Somebody saying yes. A mileage, in terms of miles and age of the car, that means how much the car has run. Yes. What else? The popularity of the car, for example, the car's model, wear and tear. Fantastic. Yeah. How many owners? Very good. Any major repair of the car, that means any accidents happened, any history. Yeah, perfect. It's petrol or diesel car, the brand, the model. How many owners were there in the car? Yeah, fantastic. I think, yeah, this is something that we can relate to. That's why I take in this particular case. So you can see that, right? To estimate the price of a car, if you have some historical resale samples are there. So that means some of the cars which were sold earlier, and we have information about at what price those cars were sold and what are the parameters of those cars or factors. For example, what is the age of the car, right? Make or model of the car, age of the car, or the number of owners, how many owners were there for the car, is the first owner, second owner, fuel type, or even transmission, automatic or manual, right? How many kilometers driven, right? Mileage, what kind of mileage the car gives, condition of the car. So all this could be different factors, right? That might influence the resale of the price. So what we can do is to solve this problem in terms of machine learning, we can go ahead and actually collect data, right? So some of the data points could look something like this, right? For example, this is the car. So we have a list of Maruti cars here, actually in my data, but I'm just showing a sample. For example, this is the price at which the car was actually sold earlier, okay? And this was the car model and make. This many kilometers the car has driven. This is the fuel type. It's a manual, automatic, the first owner, second owner, right? The mileage, even from the year of the transaction, we can, sorry, from the year of manufacture, you can also see what's the age of the car, right? And which location also, sometimes location can also be a parameter which influences, right? There could be a specific demand for a particular model in a specific location that can also influence the resale price of the car, right? So all these factors. And the question is, how do you know which factor has what kind of influence on the price? Isn't it? So that's a basis for a machine learning problem formulation. So what I can do is you can go ahead and build a model saying that the price as a function of, right, model, kilometer driven, right, age, location, and so on and so forth, right? And then you can build a model. So let's do a quick hands-on on this. So I have got a data set, simple data set, and see what we can do. So there are many tools in platforms are there. Of course, Python is one of the most important tool that actually are used nowadays to build machine learning models, but that needs a programming experience. Okay, so that's why I have chosen a tool called Orange, which is also quite popular tool, by the way. This is all UI and UA driven. So what you can do is you can actually get a file. So for example, you can import the data, right? And I've already got a data set here, which I'll just show you. Yeah. So this is the data set that is, yeah, there you go. Right. I've taken only very few variables here. For example, I've taken the fuel type, diesel and petrol, transmissions, manual, automatic. What's the owner type, first owner, second owner, or third owner, how old the car was, in terms of years, what's the car's model. This is only for Maruti cars, for simple demo. What's the mileage of the car at the time of resale, and how many kilometer driven. This is in terms of thousand, so 87,000 kilometers. And that car was actually sold at the price of 6 lakhs, right? Similarly, the other car, which is Swift, which got sold at 5.6. It is a 5-year-old. And you can see we have quite a large number of samples here, about 1,000 samples. Right. So what you can do is you can go and load the data. Okay, so this is data is loaded. And this tool actually is a very simple tool to used, build models. So you can see about 1,000 rows, 8 features. And then we can also look at the data. So there's a data table there, which shows in the tabular format. All right. And what you can do is now we can use something called, so this tool, I'll just quickly tell you. So it actually has features for loading data, preparing data, transforming, visualizing, doing some exploration of the data, building models, right? So all models that you can build in machine learning, some of the advanced models also, they're stacking, boosting, bagging, and all that. Then evaluating, right? So all the important steps are there, and all that can be done without any knowledge of programming as well, right? So once we have the data set, we can load the data. And here, if you see, it already lists out, those are columns, right? Saying that these are the features, fuel type, transmission, owner type, age, and all that. That's a target variable, right? So in the data, what we do is um, when you build a machine learning model, right? So these are the factors. So this is F1, F2, F3, F4, 5, 6, and 7, right? So 7 factors are there. And this is the target variable. This is the outcome variable. These are factors or features. This is outcome variable or target variable. We also call these are independent variables, and this is a dependent variable. Okay. So the whole idea is the target variable as a function of all these factors. That's basically we're trying to build. So so once you select the columns, right, what we also need to do is we have about how many 1,000 samples are there, right? We have 1,000 samples are there, and we need to split that into train and test, because we can't use all the data for building models. So we have 1,000 samples are there. Something like okay. So what we'll do is there is a function here called data sampler, right? Which we can use to set how to split the data. So 1,000 samples, we can probably use about 80% of that, about 800 samples for training the model, learning the function or the pattern in the data. And we'll keep about 200 aside. So once you build the model, we can actually validate whether the model is actually making the predictions. Because for those 200 samples, we already know the actual price, and we'll ask the model to predict and see what is the error. So that will actually help us to understand the how accurate or how useful the model is. So if you see, it's saying 1,009 samples are there, and we have about 808 samples in the training, and the remaining is actually about 200 samples, right? So you collect the data, you load the data, then you simply provide which are your factors and which is basically the target variable, right? And then what you do is you split the data, right, randomly. And once you split the data, then you can get into the modeling, right? For modeling, of course, there are many algorithms are there. For example, you can see there's a KNN algorithm, decision tree, random forest, linear regression, all that. For our purpose, we will use a very simpler approach, which is a linear regression. Now, what is a linear regression model? Which basically says that, for example, if you see in this data, just give me a second. So in this data, we are looking at the pattern of what the price of the car with respect to the age. And it is actually showing a negative correlation. That means as the age of the car increases, the price also reduces, which makes sense intuitively. But we also need to estimate, what is the change in the price with respect to change in the age. That means every 1 year, increase in age, how much the price drops or how much the price reduces. Right? So that's basically is getting estimated by this particular model. So what the model is going to say that with every increase in age, how much the price will reduce, the price in terms of the resale price. So that we're going to, of course, estimate across all the factors. This is only I'm showing in terms of age, right? We're going to, for example, for kilometer driven, right? So additional kilometer driven, 1,000 kilometer driven, how much the price drops, right? Or in case of mileage, additional mileage, how much the price increases. Typically, for higher the mileage, the price will be higher, right? Similarly, you can also estimate, like for petrol car, what is the premium that you want to pay, right, with respect to diesel car, right? Or how much additional resale price for automatic cars compared to the manual cars, right? All this can be estimated through this particular regression model, right? Of course, once you build the model, we'll look at that. So the build the model, it's as simple as taking this linear regression model and then feeding the data to the model, right? So let me adjust this. So you have taken the data, we have set which are the factors and which are the outcome variable. We train and test sample, and then we build a linear regression, right? And you can see it is a built a linear regression model, and it's actually also given the factors with the influence of the factors, how much is actually influences on the resale price. So here, if you see the age, it is estimated minus 0.28, right? Or probably the mileage 0.024. So that means it's basically the model is saying, what the model actually saying is with the price, right? If you look at the model, so let me look at the model again. What the model is saying here is the base price of any car, Maruti car, is about 6.41 lakhs, right? And then if it's a diesel, then you add 18,000 to it. If it's a petrol, you reduce the price. It's a transmission car, automatic, then you add 30,000 rupees. It's a manual car, you reduce 30,000 rupees, right? So it's a first owner, you reduce only about 5,000 rupees. For second owner, you reduce another 15,000 rupees, right? And every additional age of the car, you reduce about 28,000 rupees, right? So if it's about, let's say, 5-year-old car, then 28,000 multiplied by 5, right? So that's basically the model is saying. So you can actually, if you want to look at in a very base, right? Just give me a second. So price equal to, right? You can just 6.41 minus 0.28 of age, right? So every additional age, you reduce that much price. Or for every additional mileage, you add some rupees, right? So basically it estimates the particular price of the car. And then what you do is once you build the regression model, right, then you need to also validate, isn't it? You have to validate the model as well. So what you can do is you can actually also make predictions. We take the model and predict it. And from the sampler, you can actually do something like this. So you can take the remaining data, which is about 200 predictions. So we have taken the 80% of the data to build the model, and the remaining 200 remaining data we have taken for the validation. So if you look at the predictions, so this is how the model is built. If you see, so this is the 200 samples that we have kept aside, 201 samples that we have kept aside for testing, and each of the cars, for example, this particular car, which is a WagonR for 5-year-old, it was actually sold at 3.1 lakh rupees. And the model is saying it will be sold at 3.7 lakhs. So there is an error of 60,000 rupees, overestimation, right? So this car was sold at 7 lakh rupees. The model says 6.86, not bad. It's only an underestimation of 14,000 rupees, right? So if you see, every car at which the price was sold and the model's estimation, okay? And some cars, of course, the error is high, and some cars, the error is low. So overall, if you see, there's something called R square, which is tells you that about 86% accurate in predicting the actual price of the car, which is not bad if you look at, we've taken only very few variables, right? So if you add things like what's the condition of the car, accident history, right, or some additional information, you can actually increase the accuracy of the model even further. Any point? So if you see, with a very simple approach, right, we've taken the data, we simply identify the factors, and then we sample, training and test sample, we built a regression model, and we predicted on the test data and found a model itself, isn't it? And now once we have done that, what we can do also is we can go and save the model. All right, we can save the model now, and once you save the model, for example, say cars, right? And we can go and see, you can say the model is actually saved. Now it can be actually deployed for in future predictions and all that, right? You see how simple, of course, it's not as simple as this in all the cases, but um, the overall basic framework is already there, right? If you have a very good understanding of the domain and you collect a very good data that you think have influences on the outcome, right? We can actually build a model very quickly and validate the usefulness of the model and then deploy it, right? Of course, for complex models on that, Python is typically preferred, but simple ones, you can always build it, and it can actually This tool can actually help you to kind of build a very good foundation on first understanding how to build models. Then you can go to complex and build models using other frameworks like Python and all that. Okay, so I'm going to stop it here. And we can take some questions.
Yes, sir.
Yeah.
If you have any questions, you can write down in Q&A section.
I think some questions are already there.
Yeah.
Probably you can read out them.
Yeah. So first is Raghavendra Raj. When building a first machine learning model, how can beginners strike the right balance between keeping things simple enough to understand and still creating something meaningful that reflects how ML is used in the real world? How do you recommend beginners balance learning the theory versus jumping straight into hands-on practice?
Yeah, I mean, the first thing is, say for building machine learning model, you need typically three core skills, right? One is a good domain knowledge. So whatever model that you're building for a specific industry or a specific problem, right? You need to have a very good knowledge about that. Of course, um, whenever you are building models in an enterprise, you know the individual who is building a model will be a team. So at least the team need to have a right combination of skills. So people who know the good understanding of the domain. So the problem formulation is very important. A lot of people actually, like in academics or in learning, people typically start with the data which is already available, but in the real world, data might not be available, right? So a good domain knowledge will actually help you to understand how to formulate that into ML problem and where to get the data in the enterprises. And second one is that's the first. So good domain knowledge is always very important because it will also help you to understand what factors might be influencing that particular outcome, right? Which is of course an iterative process. The first step you may not be able to identify all the factors. So over a period of time, you build model, you come back, validate and add factors, and so it'll take few iterations to get a good model. So your domain knowledge is very important. Second one is understanding of the intricacies of those models, right? So which model is appropriate, right? So you have to have some knowledge of. I mean, you don't have to be a mathematician or statistician for that, but some good intuition around how these models work, right? And what model is appropriate in your case. So for that, you need a little bit of understand theory as well, right? Of course, unless you want to be a researcher, practitioners, you need to have a good intuition and understanding. I think a lot of these courses provide you, right, that foundational aspect of it. Um, so you need to have a good understanding of the domain, good understanding of the algorithms, and good understanding of the data as well, data engineering, right? How to curate data, right? How to clean data, how to prepare data, right? So data, algorithms, which might need some basic intuition, developing some intuition around some core statistical and machine learning ideas. And then, of course, a good domain knowledge. All three are important. Yeah,
Thank you for your answer, sir. Next question is, as a commerce student, can I learn machine learning?
absolutely. Absolutely. So machine learning is not a additional skill. It's going to be an important skill that everybody must learn across domains and industries, right? So we teach at different business schools. Now everywhere machine learning has become a core to core course now, right? So whether we'll actually end up building machine learning models yourself in the when you do a job or not, but understanding machine learning is very, very important because going forward, a lot of problems would actually end up being solved using machine learning and AI. So whether you come from commerce, we've also seen people coming from other streams, right? Like a journalism. Also, people use machine learning models, right? So whether you come from commerce, or science or any other aspect or engineering or non-engineering, you need to have a good understanding of machine learning, right? And nowadays, there are tools like I showed you the tool, which also does not need a lot of programming knowledge, which actually help you to, but you need to have a good domain and data knowledge to actually build these models. Okay.
Thank you, sir. Next question is, what are the other tools like Orange which are user friendly, especially for people who are from a non-technical background?
So there are quite a few other tools are there, but I think Orange is one of the best tools that actually that can be used. Okay.
Okay.
The Orange is quite widely used also. There's also K-Mine there, and there are other tools are there. We use both while teaching. People who understand programming will use Python. Of course, Python is the best if you can use. Otherwise, Orange also teaches you how to build models to a great extent.
Okay. The next question is, how much data set is good data set? I assume we should have as much data which minimum makes R square around 0.95, or how we can estimate.
No, no,
Because,
no. More data does not mean better model. Okay. Of course, we need a reasonable amount of data. So there is a relationship between number of factors and number of samples. That, of course, you will learn when you study machine learning. So if you have more factors and more features, you need more amount of data. But not necessarily there's a linear relationship. So after a certain time, the model saturates. Even if you use more data, there's no increase in accuracy. And second one is accuracy does not mean you have to get 90% accuracy in all the time, right? So you have to look at the usefulness aspect of the model. So in a lot of financial domain, when you're predicting the prices of assets and all that, typically 60% is also called a very good model. So it depends on the domain. Not necessarily every model has to have a 90% accuracy, right? So you have to look at the benchmarking in your domain and what is currently the best models, what kind of accuracy it gives. You basically aspire for that, right? It's not possible to get 90% in all domains and all problems, right? So you need to have an understanding. That's why you need to have an understanding of the domain, the literature in the domain, right? What is the current benchmarking and all that, right? So how much data depends on the complexity of the problem, number of factors and all that. And what is a good accuracy? Again, depends on the domain as well.
the next question is, does Orange also give you Python code for what we built here so that further amendments can be done in Python if required?
Yeah, it can give you, but nowadays, of course, a lot of this code generation tools also give you that a much better way of doing it. Okay, for example, your cursor or your ChatGPT or Claude also can give you. But once you have a good understanding of the foundations, right? Simply generating the code doesn't help you. So once you have good understanding, you can actually use some of these tools to generate code to deploy.
Okay. Next question is from Krishna. If I want to start learning machine learning or AI from scratch, can you please guide?
But join a course, right? Because the courses are designed for incorporating that skill into you, which actually the curriculums are designed very well. So it takes you step by step approach, right? Of course, if you want to learn yourself, a lot of materials are there, but then typically people who learn right themselves can actually lost in this, get overwhelmed with the information available. So joining a good course can actually help you, build that skill. So you have to spend that time, right? About 1 year, because you have to start from basic statistics, machine learning. Quickly learning something to do probably not going to help you, but you have to invest that time to learn the skill, very systematic way, right? So that's very important.
So this is the last question for the day. If the model creates illusion, even if in the prediction stage two, is there any further validation steps?
Oh yeah, yeah. The very complex validation processes are also there, right? Cross validation, k-fold cross validation, right? Estimating the uncertainty in predictions, right? There's a complex theories there. So there is extremely well-defined validation steps out there: overfitting, underfitting, bias, and variance, right? We need to understand all those aspects to build a good model. Mm.
Okay. Thank you so much. Thank you so much, sir, for the session, for such an insightful session. Thank you, all the candidates, for joining this session. We look forward to you all to join the next session as well. We'll surely share the link for the next sessions as well.